All right, good morning and good afternoon, class. I'm really sorry that I'm not there. Last night I randomly got sick, so luckily it's pretty easy to record these videos. So today what we're going to be doing is we're going to go through that 1.10, the gold homework that you have. Hopefully you've already worked on it, and this is going to be correcting your work. If you didn't finish it, another warning, hey, make sure I would prioritize that homework if I were you, especially because today the goal of what we are looking at is, up to this point, I have been checking your homework off for completeness. Have you been doing it? I haven't really even been looking at your answer. Oh, I have been looking at your answers. I have been judging them, but it is not factored into the scoring. The scoring has been based on completion because when we're learning to do something, it's important that you just do it. For instance, as I've been getting into running, over the last year now, it's been about doing the miles. It's not always about doing it fast. If my calendar says, hey, it's a 10-mile day, and I have to walk 3 miles because my legs give out at 7, as long as I finish the miles, that's what matters, because at the end of the day, crossing the finish line is my goal. That is your goal in this class at bare minimum, is you are going to cross the line of passing. You're not always going to like doing the thing. That's okay. You don't have to enjoy it or like it to finish it. So we're going to look at the homework. And one of the first things that you should be doing as you're doing the homework, and I'm going to go through this as if I am doing the assignment. Please pause the video when you need more time to write it down or to discuss with other people. That is up to your sub to kind of decide, hey, this seems like a good point to discuss. But I'm just going to do this assignment as if I were working on it. So the first thing I do when I start a new assignment is I look at each question. And I try to decide, okay, is this question going to be kind of on a scale of 1 to 3? Is this going to be really hard? Is this going to be kind of hard? Or is this going to be easy? So looking at this first one, I got a data set. What's the median? What's the IQR? That in reality is going to be medium. It's tedious, but not very difficult cognitively. Question 2, okay, what's the mean and what's the mad? Okay, that one is going to probably be a pretty big task. Question 3 seems like a really easy one. Describe the shape, but notice I left a lot of space when I made this assignment. So maybe that's a hint to you that this one probably, where this one is definitely a hard, this one that seems easy but has a lot of space under it should probably tell you, hey, as much as you think it's an easy, you might want to up that to a medium in difficulty. On the backside, okay, question 4. What's the median? And they give me a box plot and 0 workspace. That's probably simply easy. 5, select all that apply, and it gives me a distribution, asks me about the shape. That one is also probably easy. The dot plot below represents whatever it does. We'll get there later. What's the mean? Okay, kind of getting into the hard. What's the median? Okay, that part's easy. Okay, comparing which one would a box plot let you find. Okay, I'm probably going to label this one like the medium to hard, because mean, very tedious and difficult to calculate, especially because we're not used to doing it. Median, pretty easy. Now, at this point is where for you, you can decide, hey, I want to do them in whatever order you want to do. Personally, I always do it in numerical order. Unless a question stumps me, I'll move on past it. But if you're someone who wants to go with, I'm going to do the easiest questions first, go for it. If you want to do the hardest questions first, go for it. That is up to you. But like I said, I'm a sucker for, I have to go in numerical order. So, what's the median? The first thing we need to ask, is this a well-ordered set? And yes, it is. 5 is less than 6, 6 is less than 8, 8 is equal to 8, 8 is less than 9. Yep, this is well ordered. So all we have to do is go 1, 1, 2, 2, 3, 3, 4, 4, and we got 2 in the middle. So we find the middle of those two things. So what's the difference between 9 and 9? Well, 9 minus 9 is 0. Half of 0 is still 0. 9 plus 0 is 9. So that's a very quick and easy way that you can kind of find the middle between two numbers, is subtract them, find the whatever the difference is, divide it by 2, and then add it to the smaller number. So in this case, the median is 9. But notice the question isn't over yet. Interpret this value in the situation. This is your hint that you are writing a sentence. So in this case, our sentence has to talk about this is the number of errors on a typing test. So students, actually I'm going to change that start. Half of the students made more than or less than 9 typing errors. And they're good. And then we go back and we start reading that sentence again because we want to make sure, does our sentence make sense? The median is the value where half of the data is less, half is more. Half of the students made more than or less than 9 typing errors. Hey, that is in fact what we are trying to describe. And remember, that is a box-worthy answer. So we throw a box around it so we know where that answer is, and we can avoid all of this extra scratch work. Now, the IQR, I need to, and I'm going to use a different color so you can kind of tell it apart when I'm working on that setup there. IQR is Q3 minus Q1. So we need to go find Q3 and Q1. So my median was right there. So 1, 1, 2, 2, Q1. 1, 1, 2, 2, Q3. So my Q3 is 10 minus Q1 is 8, gives me 2. So I would write over here, that's my scratch work. IQR equals 2. And that is a good box-worthy answer. We throw a box around it. So as we're looking at this one, this is, and this is true of all of these questions, this is the amount of work that I expect to see as you are working through these problems. And this is how I expect your work to look. You can have your scratch work off to the side. You can even take your scratch work and put it on a separate sheet of paper and then just staple it to your homework if that is easier for you. If you're like, I want to have just a blank canvas that I can work on and I want the homework assignment to be my answers only, you can do that, but I still want to see that scratch work for now. So for question 2, this one, we're going to be here a little bit longer. We know this one's a little bit deeper of a question. So the data set represents the heights in centimeters of 10 model bridges made for an engineering competition. What is the mean? So here's where we just have to take and we have to add these together. Now I'm going to combine things first so that I have less addition. Because in my head, I can just look at these two and go, hey, 14 and 14 is 28. 16 and 16 is 32. 16 and 16 is 32. 18 and 18 is 36. And now I've just taken my 10 numbers and I've reduced it down to where I'm adding 1, 2, 3, 4, 5, 6. So I've reduced it slightly. I can keep going on this and I can say, hey, well, this one is 64. Well, wait a sec. What's 64 and 36 make? That makes 100. So now I've got 13 plus 28 plus 100 plus 19. And I've just eliminated this giant chunk of numbers from what I have to deal with. And I've shrunk it down from 10 things I'm adding to 4. So you are in charge. You can decide the way that you want to add these. 41, 19, 60, and 100 makes 160. So we notice, was it hard? Hopefully not technically. Was it tedious? A little bit. And you can take as much space. If you need to just go 13 plus 14 plus 14 plus 16 plus 16 plus 16, if you need to do it that way, do it. I don't care how you get to this number as long as you are not using a calculator yet. I want you practicing doing it by hand, because someday, as much as we all talk about having a calculator on us, one, it's important that you know how to do things without it. You don't want to be beholden to it. But also, there are going to be a lot of times as you get older and you're adding things together where you left your phone in the other room and you're not going to want to go get it. And you want to make sure that you know how to add these things together without it. But also because in this classroom we're earning our calculators, so we haven't earned them yet. So we're going to be practicing still this way. So our definition of a mean, I thought I was using a pen, is that x bar equals the sum of the set over the number of items in that set. So this is 160, that was our sum of s, divided by, and they tell you here that it's 10. My advice, unless it's a really big problem, if it's a huge problem and it's on a big test, you might go ahead and just trust that. But when it's 10, I always count it. I don't trust anybody, including myself, when I type up an assignment. So I like to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and just confirm before I put the number there for that. So now 160 divided by 10 is 16. So I can nicely declare here that x bar equals 16. And that is our mean. And now I want to address a mistake that I'm seeing a lot from people. The mean should be in your data set here. If you are looking at this thing and you are noticing that your mean for this, say you got a mean of 1.6. It's like, okay, 1.6 is way down here. That is not in the data set. That is wrong. If your mean does not occur in your data set range, not necessarily is it a value in your data set. Our mean could have been 15 and that would have been reasonable. But it has to be between these two things. Also, if you're sitting there and you're like, oh, my mean is way out here, I got 160. The fact that it's not in this range is telling you that it's a mistake. Because what the mean is saying is, hey, if we had a situation, I'm going to draw a little picture here. If we had a situation like this, the mean is asking, what do you need to do so that every single one of these rows, 1, 2, and 3, so that all 3 of these have the same height? So in this case, you would take that square and you would put it right here. And now all of them have a height of 2. That is what you're doing with the mean. It is saying, take the value that makes everyone equal in size. So we got our mean. That is now foundational and massively important to finding our MAD. Now, on this MAD, we need to first write out, okay, this is the MAD of u using that function notation, and then we always write the formula that we are using. So the formula for MAD is the sum of the absolute value of x sub I minus x bar all over n. So we got our formula and we're going to start filling it out. Now, this means we've got the absolute value of 13 minus 16, And I highly recommend make these bars really big to where it is obvious that it is not a number, because otherwise you start looking at this and you're asking yourself, why do we have 113 minus 161? And it's going to get really confusing really fast. Then that summation means that we are adding it. So we did the first element in the set minus the mean plus the second element. Sorry, my iPad is deciding to wig out. The third element. And then I'm going to be very honest with you. This is where you can look at and go, okay, the mean is 16. I've got 4 16s here, and I don't have as much room as I would like to add that all out. What is 16 minus 16? Well, 16 minus 16 is 0. 0 in absolute value is 0. If you add 0 to anything, does it change a value at all? The answer is no. Hopefully you all resoundingly were shouting it at the sub. So we throw in the next value. I'm just going to skip the 16s for both my sanity and space. But notice here how I didn't just skip it and not say anything. I have justification here. And if you want, you can draw a little line there. I am justifying over here why it is that I find it reasonable to skip that step. I'm still doing the work, but you don't always have to write it in the same order here. But as long as you're communicating clearly what you are doing, that is the key to mathematics. And all divided by 10. So then we have to ask ourselves, okay, what is 13 minus 16? 13 minus 16 is negative 3. Well, the absolute value of negative 3 is positive 3. I'm going to scroll over a bit. Actually, what I'm going to do, I'm going to take this whole thing, and for myself, I'm going to move it. The beautiful thing is you can kind of fill in the margins as you need. Apparently my pen disconnected there. So I've got 3 plus 2 plus 2 plus 2 plus 2 plus 3 all over 10. Well, that is 2, 4, 6, 8 plus that. 8 plus 6 is 14. So 14 divided by 10 gives me a MAD of U, or 14 over 10 gives me a MAD of S equal to 1.4, and that is my box-worthy answer. Now, let's talk about what does that MAD mean here. That is telling you that the majority of the data is within 1.4 of the mean. So I'm going to switch here to a green. This is a side note that if you have this, so if you had 16 minus 1.4, that is going to be 14.6 up to 17.4. So if we're looking at this, is the middle part of the data of this set, is the middle chunk within that range? And the answer here is yes. The middle 40% of the data is here within that MAD range. This is the whole point, is that you're essentially setting a radius and going, hey, who's reasonably close? And as you go out further MADs, you get a bigger and bigger region that captures more of this data. And that's how you determine, hey, am I dealing with something reasonable? So for instance, 2 MADs out would capture this region here, the dotted lines. And that's where you start to say, hey, you are far more likely to be a 16 within this negative or 14.6 to 17.4. You're far more likely to be within this range. But if you're not within that range, you're almost guaranteed to be in this range. And then we start to get into the, well, it's really unlikely that you're out here based on the parameters of these sets. So we're going to keep playing with that. If you're still hearing that and you're still going, what is going on? I don't quite understand what you mean. Don't worry. We're going to keep talking about it and we're going to keep discussing what it means for quite a while. I'm going to keep hammering it no matter what comes of curriculum. Number 3. Now, I mentioned this on the side of the board a few times. Today, we're going to implement it. When you're asked to describe a distribution, you should go with the good old trusty SOX. This is the acronym for describing the shape of a distribution and just overall what is going on here. So that first S there stands for the shape. Hopefully, after our long Kahoot that everyone was acing everything, you should look at this and say, that is skewed right. Now, when you're answering SOX, you need to write in full sentences. So this is a dot plot displaying the golf scores from a golf tournament. So the shape of the distribution. So the shape of the distribution of golf scores is skewed right. And we know it's skewed right because the tail on the right side is longer, being pulled that way. To determine if there are any outliers, that's going to be some scratch work. I'm going to do that in black here. We need to find Q1 and Q3. So we need to find out, okay, how many things do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've got 20 things, which means that my median is going to happen at the 10th and 11th item. Because think about, if I cancel out on the left of 10, I'm going to have 9 things. On the right of 11, I'm going to have 9 things. So if I find those 2 things, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, these 2 are going to be my median. Oops, I don't know why my app is closing. So my median here is 135. That's going to be useful later. Keep in mind that's going to be right between those 2. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 things there. So the 5th and 6th items are going to be my Q1 and Q3. So 1, 2, 3, 4, 5, 6. So Q3 is 137. And then 1, 2, 3, 4. Whoop. Keep going backwards. 1, 2, 3, 4, 5, 6. So these 2 make up my Q1. So the middle of 135 and 134 is 134.5. So Q3 minus Q1, 137 minus 134.5 is 2.5. That is my IQR. Now notice, this is scratch work. This is just what sometimes you have to do to get an answer, especially in statistics, is the question they're asking is not necessarily the numerical part. So we take this, I'm going to go ahead, I'm going to help you out here. 1.5 times that IQR in this case is 3.75. So to determine outliers, you'll want to go back and look at your notes for the definition. If you are feeling lost right now by what I'm doing, we are taking 1.5 times the IQR and we add it to Q3. So in this case, 137 plus 3.75. And you can actually go through and do this math, but I want you just to think, okay, 137 plus 4 essentially is 141. So we're going to be closer to 141 than anything else. Do I have any values that are 141? Hopefully you're shouting no. Same thing on this side, and I'll do it over here. 134.5 minus 3.75. Well, I have basically 4 being subtracted from 134. Do I have any values that are close to 130? No. So here we would say there are no outliers. There are no outlier scores. Our center, that's just another way of saying the median. So the distribution of golf scores is centered on 135. Notice how all of these sentences you could read and you should know what is going on. It should not rely on you to know what is happening in the story up above. You should be able to read the description and know what's happening. The final S is for spread. So that is the minimum minus, or the maximum minus the minimum. So the spread of the distribution of golf scores is 140 minus 133 is 7. Is from 140 to, or sorry, that's backwards, 133 to 140. And then I always like to add this part with most of the data between 134 and 136. Because that tells us, hey, this is where all the data is, but if you look at it, most of it's right there. So what I want you to do right now, I want you to, you'll pause the video in a second. I want you to stand up. I want you to walk to the other side of the room, and I want you to tell someone else one thing that you've learned so far. And if you're sitting there going, oh my God, I don't want to move across the room. I don't want to go talk to someone on the other side of the room. I don't care if you stand up and walk to the other side of the room with your partner, you sit by and you talk to the whole class. You can just walk across the room with them. But the key part here is I want you to get up. I want you to move, do some calf raises, do some sort of any movement to get some blood going through your body. And we'll continue, with question 4 here after you've done that. All right, so question 4. You ideally should be looking at it and going, this feels too easy. And you should say, okay, well, the median of a box plot is that center line of the box. Median equals 118 degrees Fahrenheit. And then you box it and you say, that's a box-worthy answer. And you move on. Box plots, really easy to find anything from the FNS. Question 5. The dot plot shows the weight in grams of several different rocks. Select all the terms to describe the shape of the distribution. So, looking at this thing, is it unimodal? Does it have a single peak? No. Cross it out. Is it bimodal? Yes. It peaks twice. Looks like an M. Is it skewed? No. You could not possibly describe to me a more perfect example of uniform. It is, or sorry, of not being skewed, of being symmetric. And is it uniform? No. Now, A, C, and E are all tied together. That if you had chosen A, you could not choose C and E. Any of these ones, these are what are later on going to be called mutually exclusive. You cannot be unimodal and bimodal. You cannot be, whoops, sorry, I said B and then I wrote C. A, B, and E. These ones are mutually exclusive. You can't be A and B or E. You have to be one of them. So it's always nice when you get these on any sort of multiple choice question because you can just instantly eliminate them. C and D are also mutually exclusive. You can't be symmetric and skewed. And we'll define more formally later on this idea of mutually exclusive. But I'm teasing it out here. So, as we're looking at this, whenever you have a multiple choice, what I always ask, off to the margin, write what it is that you are selecting as your answers. The main reason I like this is when you have a shape like this, or any sort of thing like this, people tend to be really sloppy with multiple choice. So if you circle something, erase it, circle something else, erase it, circle the first thing again, it gets really confusing. Whereas if you just write off to the side, this is what I'm choosing, it is a final declaration and it just makes it really nice for me to deal with. So the last one, what is the mean of this dot plot? This is the distribution of 1 week earnings for college students. So we're right back at it again. We're adding up these numbers. So we need to first go in and get the numbers. So we've got 112 and 113. We've got 3 times 116, 2 times 118, 2 times 119, and then 3 times 124. So then, notice I already just used multiplication to kind of simplify what I've got. We're just going to go ahead and I'm going to do some scratch work calculations. So I'm going to write it and then I'm going to erase it. So if you have a piece of scratch paper, you can do it there. You can also use your margins however you want outside of the question. I just want to make sure that my work looks nice for you. So I'm going to do 116 times 3. 18, 3, 4, 348. 118 times 2. 6132. And feel free at any point if you're watching this and you need to pause it, this will be on Canvas for you as well, so you can watch it there. But feel free, you can just pause, and if you need to multiply things out, that is a-okay. So now I've simplified this. Now I can just start adding things together. 112 and 113 is 5, 2, 2. 225 plus 348. And you should end up with a sum here of 1419. So my formula for that, the sum of, this is, I'm going to call it C for college students, divided by N. So I've got 1419 divided by, this is 12 here. And this is where, hey, guess what? We get to do some long division, everyone's favorite thing. And remember, our whole goal here is this hard? No, it is just tedious. It's just doing little steps that are all stacked on top of each other, and that is what math is. You start with little blocks and you put them together until you make something massive. So how many times does 12 go into 14? Goes in there once. How many times does 12 go into 21? It goes in there once. Twelve goes into 99 8 times, because 8 times 12 is 96. Oh, I'm going to run out of room. I'm going to move this up. And this is why that multiplication is so important. Don't forget, you're going to have another one of those earning calculators quizzes coming up here, your next A day. Twelve goes into 60 5 times, and that's going to end up giving you a remainder of 0. That looks like a 6. So we have x bar equals 118.25. Now we need the context. The mean amount earned by these college students in a week was $118.25. And we've got a nice box-worthy answer. To look at. So we found our mean, our median. We just are counting through the set. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And it's the middle of those two. What's directly between 118 and 118? 118. So median equals 118. So half of the college students earned more than or less than $118 for the week. All right, now we're down to our last one, and this is a question about whether or not you understand the distributions you're looking at. So would a box plot of the same data have allowed you to find both the mean and the median? A box plot, remember, shows you only your FNS. In order to find the mean, you need all of the data. So our answer is no. A box plot would not allow us to calculate the mean. And that is it. So as a reminder, this is what I expect to see as you go forward on your homework. I will be moving towards grading more on not just completion, but correctness of if I'm looking at your homework and it's obvious to me that you did not get the point, you did not understand it, I'm going to tell you that, and I will let you know, hey, it's not correct. You need to fix this. You need to come to office hours. Um, we'll talk about what that means for grading it in the future. But what I want you to work on right now is I want you to go through this. And since I'm not there to collect your definitions, you've got even further grace. I want you to work on those definitions. I want you to study those definitions because, as a reminder, the end of this week is your vocab quiz. Have a great day, and if you have any questions, please come to office hours. I will hopefully be back at school tomorrow.